Hello everyone, and welcome to today's webinar, Unlocking the Power of AI for Unstructured Data with Integrated Link Analysis. My name is Jean. I'm one of the co-founders of Linkurious, and for today's webinar, I'm delighted to be joined by Stephen.
Good day, all. Thank you very much, Jean. Pleasure to join. I'm Nuix's Field Chief Technology Officer. Been around Nuix for 16 years and thrilled to be working with Linkurious to solve some of these really exciting problems.
Awesome. So let's get started. So first, maybe a quick word about Linkurious. For those of you who are not familiar with the company, so we were created in 2013. We have two offices, one in France, another one in the US. We are a team of 50 plus employees, and on a daily basis, more than 10,000 analysts throughout the world are using our products to make sense of complex connected data.
Yeah. And so Nuix, we've been around for over 20 years. We basically have 1,000 different customers, probably tens of thousands of different sort of people have been touched by Nuix. We have 11 offices globally, 400 plus employees. And really sort of the key element around Nuix that has sort of led us together is really that sort of top middle number, which is really sort of the 1,000 plus file types that we're able to consume, normalize, extract text and metadata, and make useful.
Awesome. So let's talk a little bit about today's agenda. So we are going to start by discussing how to leverage leveraging unstructured data in complex investigations can be indeed complex. Then we'll discuss unlocking the value of unstructured data with NLP, which is natural language processing, and graph analytics. And then we will have some time for a demo, and afterwards we'll do some Q&A. So feel free to drop questions throughout the webinar. So with that being said, let's get started. So leveraging unstructured data in complex investigations. I guess a lot of you are familiar with the fact that in complex investigations, it's critical to understand the context around the entities of interest. Here we have a bit of an example of that. We have a seemingly good and normal client, I guess, on the left. And if we just look at this particular individual in isolation, we may not notice that there's some risks that are associated with this individual. But if we look at the context, the connections surrounding that individual, then we can realize that indirectly he or she is tied to a non-fraudster or criminal that we see on the right in the red circle, and that can inform our decision making, because all of a sudden that seemingly normal person appears much more risky. So that's sort of the insights that understanding the context around the entities of interest can help achieve. And typically, for a lot of the organizations that we are working with, we see that they are focusing quite a bit on unstructured data. There's a reason for that, because it's easier than unstructured data, and also because there's a lot of value, I guess, in this structured data. Let me give you some examples. So it can be financial transactions that's highly structured. You typically have a recipient, someone sending the money, a timestamp of some sort, and an amount. So highly structured. Phone call records also highly structured. You have a person making the call, another person receiving the call. You may have some metadata associated with the call, such as a length, a timestamp, these sort of things, but also fairly structured. You have the same thing for emails, for example, and that's really the sort of data that we see a lot of our clients and partners focusing on. The issue is that not all data is structured. Actually, this is quite a bit of an understatement, because according to IDC, up to 80% of data is unstructured. And even more, 90% of the unstructured data, also known as dark data, is actually never analyzed. So when you're actually focusing on structured data, it's a little bit akin to looking for your keys under a lamppost, because you are simply ignoring a lot of information that's out there. So what do we talk about when we are talking about unstructured data? So here you have a bit of an overview of different data types. This is actually the various data formats and data types that are supported by Nuix Neo, and we will talk about that in a minute. But you can see the breadth, the diversity of these different data formats. So you have, human-generated content, digital and mobile forensic data, network data, user data, real-time feeds, enterprise cloud repositories, and more. So quite a bit of a diverse range of types of data. And when you zoom in, then you have even more actual data formats. Just looking, for example, at email files and databases, you can deal with Microsoft Exchange proprietary formats or Microsoft Outlook. There's also IBM Lotus Notes, Microsoft Outlook Express, and of course, a bunch of other email clients such as Box, EML, EMLX, SML, and more. So I will give you, a couple of seconds maybe to digest this slide and look at these various formats. But the point is really that unstructured data, it means a lot of complex and diverse data formats. And once again, all of these formats are actually supported out of the box by Nuix Neo. So we just mentioned that it's really we just mentioned the breadth of unstructured data. What I would like to stress now is that this data is actually quite useful. So talking about fraud, for example, if you are doing insurance fraud, you may want to look at the content of claim reports because that's full of information. In law enforcement, it's one thing to look at phone call records and to know that person A has contacted person B, but it can also be interesting to actually learn about the content of the conversations and what this content can tell you. In anti-money laundering, financial investigation units are dealing with suspicious activity reports, which are inherently very unstructured. Similarly, in life sciences, you're probably also looking at things such as scientific articles, which once again are unstructured. So a lot of the data out there is actually unstructured and can be fairly helpful. And there's actually a whole field of technology called natural language processing, or NLP, that helps with making sense of unstructured data. And specifically, in the context of today's presentation, what I want to focus on is the fact that NLP can help extract entities and relationships out of unstructured data. And here we have a bit of an example of that. We can see a text on the left with some entities that are highlighted, and once these entities and their relationships have been identified, then we can use that as an input to create a graph such as the one that we see on the right. So NLP is very, very powerful in terms of helping make sense of unstructured data. The problem, though, is that leveraging unstructured data investigations is difficult. And it's difficult for a number of reasons, and mainly because NLP expertise is rare and hard to find. There's also the issue with the fact that it's difficult to identify entities and relationships within documents. And the results need to be highly accurate to actually deliver value. And before that, the advent of machine learning and AI, it was, there were some technologies out there in terms of NLP, but they were simply not accurate enough to deliver meaningful results. Another big issue is the need to adapt NLP models to particular domains. The dirty secret of NLP is that there's no one-size-fits-all sort of model that could work across different scenarios. A model that's going to do a great job for scientists trying to make sense of patents and scientific articles is not really going to work for a corporate lawyer looking at contracts and trying to work on anti-competition cases. So you need to have domain-specific models to have effective results in terms of NLP. And if from one investigation to another you are switching context, switching data sources, then all of the issues that I just mentioned are going to be just amplified. The net effect of all of these causes is that the use of unstructured data in investigations is out of reach for most investigative departments and organizations. Unless you have the budget of a small spy agency, chances are that you're not going to be able to effectively leverage NLP in your investigations and to get the full value of your unstructured data. And that's definitely something that we have seen in the field at Linkurious. We have seen partners, clients struggle with a limited set of options to leverage link analysis within their investigation process. So some organizations are doing manual analysis of connections. So they have the tools to index the data and to search it. And that's what they start with. But then when it comes to understanding the connections, it's a very manual and labor-intensive process. They look up, for example, an entity, the name of a company, such as Linkurious, identify the documents in which it's listed and try to manually identify what it can be connected to. Bottom line is it's very time-consuming. You're going to miss key insights, and the whole process is simply not scalable. A second approach is focusing the analysis of connections to the structured data. And basically, I guess at Linkurious, it's what we have done with a lot of clients, basically helping them integrate their structured data into a graph database, and then using more software to search and visualize this data. The problem with this approach is that you're going to miss some insights that are related to the unstructured data, and it can be the difference between having a successful investigation or failing to spot critical pieces of information. And finally, some organizations can build bespoke NLP and graph platforms. They can integrate NLP technologies and graph technologies to create an end-to-end solution. The problem here is that it's typically a very resource-intensive process. These platforms have limited flexibility, and of course, they're quite expensive. That's why we have decided to partner with Nuix, and together we have built a turnkey NLP and graph platform. So it's about integrating the best of breed technologies in terms of NLP and graph analytics to be able to both extract entities and relationships from those unstructured data, but also then have the full capabilities in terms of detection, visualization, and search to make sense of the resulting knowledge graph. And the idea with providing such a turnkey solution is that it leads to a fast implementation. It's also highly flexible, and of course, the total cost of ownership is, we think, quite attractive. So that's it for a bit of an introduction to unstructured data and the investigation process. And now I will pass you the baton, Steven.
Thank you, Jean, and welcome everyone. Good day to all. Again, Nuix is really excited about this opportunity and the partnership, and really sort of the idea of being able to, just as the slide said, to really unlock the value of unstructured data across really all of your different disparate silos of data. So for a long time, Nuix has sort of really been the leader in extracting text and metadata and making all of that information searchable and useful and all of those things. But really sort of the key element is, how do I go from all of this raw material? So essentially, as Jean was referencing, the data that is, essentially 80% of your data is unstructured, 90% of that is dark. But how do I sort of take that and really sort of drive meaningful and informed insights? And so when we really think about it, it's how do we do that? What's the process we drive that through? And sort of, again, what is the powerful visualization to really start to understand those relationships? And so the first piece that takes place is you really have to extract the information. And so again, this is really sort of Nuix's forte, which is, Jean was walking through the slides, and sort of you have all of the different types. And so we call those the 10 dimensions of data. So that's everything from human generated data to log data to data that exists in email archives or other cloud repositories. But essentially that 80% of stuff that's basically floating around your organization, and sort of, really trying to draw insights, not just from sort of data that exists on, file servers, but how might I like to correlate that with complaint systems or other structured data? And so again, that all starts with being able to extract that information, normalize it, and essentially get to good, clean text and metadata. And once we have good, clean text and metadata, we can start to do things like transform. And so the language, sort of around ETL, extract, transform, and load, the ability to transform that. And so when we transform it, that's really where we run it through NLP. So we extract the text and metadata with the Nuix engine. We then enrich it with NLP. And that enrichment includes everything from classification, categorization, but most importantly, fact extraction. And that fact extraction is really what leads to a highly accurate and curated knowledge graph. So one of the biggest problems that sort of we've encountered with knowledge graphs, and oftentimes why knowledge graphs lend themselves towards structured data, is it's just too easy to overwhelm a graph with sort of too much information. And essentially, the old adage, garbage in, garbage out. The ability to extract that information, then thoughtfully curate it programmatically, not by hand, and inject it into a graph such that it can be visualized, is really of paramount importance. And so it's that process by how we drive it from end to end. And then once it's operationalized, essentially that's then how you can start to interact with it, how you can search it, query it, manage it, ask it questions, like, how is this individual related to this individual? Is there a path between this financial data or this document and this individual? And so all of that is sort of the power of the graph that everyone sort of is interested in. But really the piece that we're unlocking today is, how do you do that across all of your sort of really diverse unstructured data types? So your emails, your documents, how do I fold in open source intelligence? How do I look across log data and essentially make all of that sort of useful in a timely fashion? And so with that, you got to start with, how do I get the data in? And so again, how do I get the data in? You run it through the engine, and it's really any type of unstructured information or even semi-structured, and we can connect to database as well. But you've got to get the data in there. You've got to drive that process, make it extractable, make it useful. The next phase is that you then really sort of jump in and you start to understand, what is that? And so when we talk about that, we're going to take a tour in the demo of basically the NLP model builder, and how you can come with an out of the box experience, but how you can tailor that in to focus on different things that are relevant to your business. So it's definitely feature rich out of the box, but we acknowledge that one size fits all is not good enough for everyone. And that's really where how we differentiate our thinking, is that there are a lot of cloud sources to be able to do this, and they do different aspects, but the reality is they're generic. You may have very specific needs around sort of how information is contextualized in your environment, what type of documents you have, what type of data you have, what type of entities that you may be looking for, whether they're regionally specific or specific to your corporation. What you need. And the most important thing is that you can define and build these models without being a data scientist. So again, when we talk about the value of, an integrated end platform, it also means no data scientist required. You don't have to have a team of people training and building models to try to get value out of these systems. you can really essentially let the Nuix engine do the text and metadata extraction, pull the data apart, feed it through NLP for enrichment, then push the relevant information over into the graph. And now I have an integrated system that allows me to do that ETL, but also sort of the visualization and the analysis across all of those different disparate data types. So again, it's really trying to push and drive that full end-to-end experience. And then that last piece, we're essentially looking at how this data manifests itself. And so when we think about the componentry that drives this, it goes through the Nuix Neo engine. The information is extracted. We then are writing the data to memgraph, who's a partner in our solution, high performance in-memory graph. And then we're sort of leveraging Linkurious for visualization, but also being able to link back into the Nuix Neo infrastructure. And so really that virtuous circle of being able to extract the data easily, enrich it, and basically push it into a graph for easy visualization is really powerful. One of the other things that I really think that we don't necessarily reference enough in these contexts is oftentimes we focus in on the visualization and just sort of how I can navigate the UI and ask the questions. There's so much more to basically this solution, from the types of data that you can inject into it to the types of things that Linkurious can do around alerting, publishing graphs, easily extensible to be able to ask and answer new questions. So from a partnership perspective, one of the things that was most exciting about sort of getting together with memgraph and Linkurious is this ability to really come with a great capability out of the box, but then to easily extend it to answer new and different questions that our customers and partners come up with without a tremendous amount of engineering. Essentially, we've architected the framework so you get tremendous value out of the box, but then it's really easy to extend that to that next level of specificity for your organization. And so when we sort of drive all of these things together, and we start to think about what does it mean to apply Nuix Neo and Linkurious Enterprise for complex investigations, it's really the ability to sort of take that source information, whatever it may be, push it through a process that you can reliably count on to extract the text and metadata. So again, I sort of didn't touch on too much of the types of customers that use Nuix, but of those 1,000 customers, they are law enforcement organizations, they are regulatory bodies, they are corporate entities, they are law firms, they are advisories, they are tax and auditors. And so that idea of being able to have the forensic precision of how Nuix extracts text and metadata and make that information available for search is really sort of at the bedrock level. We then run that through NLP. And when we run that through NLP, we do things like extract, as we call fact extraction. But we use that to extract PII or PHI or other entities and contextualize them with what we call compound lexemes. We then sort of drive that across the fast and efficient infrastructure that allows us to drive that through Nuix, write the graph and write the nodes and edges into memgraph, and then visualize them with Linkurious. But again, that sort of virtuous circle of being able to do all of those things without really, either significant user intervention or really any user intervention. And it's that idea of being able to essentially drive that process really fast and efficiently that really starts to allow us to differentiate what we're doing. And so I guess with that, I think it's probably time to cut over to a demonstration. So let's see what we've got. So I saw a question about memgraph or Neo4j. So today, as part of the Nuix Neo package, we basically are writing our nodes and edges to memgraph as part of the Nuix Neo solution. Linkurious does support Neo4j directly. We're just not writing directly to it today. So that was sort of a question to Louis. And so before I sort of jump in, all right, well, I guess at this point I'll jump in. Okay, so looks like everyone is seeing my screen, which is good. So for those that are familiar, this is, or not familiar, this is effectively Linkurious. This is the graph exploration engine, graph exploration visualization layer. And so what we've done is we've started out with something pretty simple. We've essentially used the system to find essentially and extract a Bitcoin entity. And sort of within that, basically the Bitcoin extraction allows us to then essentially do everything that you would normally with Linkurious and essentially drive out and understand the nodes and edges and the relationships. So here we have pushed in documents. These actually documents have to be email. We've also pushed in OSINT, so essentially open source intelligence reports. And so the first thing we'll do is sort of jump in and say, let's take a look at all of our neighbors. And so quickly we can see, we have effectively 12 documents. Each one of these documents has multiple sort of other pieces of information that have been extracted. Again, the important distinction about this knowledge graph that we're looking at is all of this information has basically been built programmatically. There's been zero human curation of this information. We pushed it through the process, extracted the information, and have driven it to the graph. And so here, we then have 21 sort of references within our OSINT, but that's not super exciting. So let's sort of take that next step, expand. And what we'll do now, is let me grab all these guys, select them all. And then I want to expand. And, oops. Sorry, having a little bit of a click fest here, sorry. Come down here to more options. And from more options, basically when I can look through, and these are all the different types of edges and nodes that are sort of related. So I may want to add sort of other Bitcoin addresses, date of births, but really what we want to focus in on is something like person. So we'll come down here to, let's see, scroll on down to P, grab a person, expand that. And so now what we've got is we have all the basically the different person entities that have been extracted from these individual documents. And what we can see is that we have a little bit of overlap, so we've got, Mother Doris Killian, she's obviously got 3, Jesus Christ apparently is in there 10 times. But we also have sort of the curious relationship, which is I have this document is basically, again, it's a document that we've extracted the text and metadata. I also have this OSINT record, and it relates to this one individual, Oliveri. And so oftentimes when you're looking at graph relationship data, there isn't a way to sort of jump in and look at the individual text of that information. So what we've done is allow you to sort of take that item and jump out and visualize it, or actually sort of view the full text within Nuix Investigate. And again, this is all part of the Nuix Neo platform. And sort of, again, the overall integrated solution. And so by then being able to go from a node and edge view and being able to jump directly into the sort of textual search view, I can now come in and sort of see the full text of the item. And so what we've done is we've jumped from the graph view into essentially the search and tagging view. And so once you're in the search and tagging view, I can obviously review the item. I can look at any of the items associated metadata. And so when I'm thinking about conducting that complex investigation, oftentimes the records that are in the graph are just that. They're just the structured piece. But once you start to work with unstructured data, there's a lot of depth and there's a lot of context to that. And there's all of the other associated bits and pieces. And so here we're able to see essentially all of the text of the individual items. I could do things like if I needed to tag this. And again, this is a full collaborative environment. So if I have multiple analysts, multiple investigators, all working in this environment, they can all be working together across this corpus. And so as I come down, I see different pieces of information. I see different names referenced. I can see down here the individual Bitcoin that was targeted. So I've got lots of different sort of ways in which I can sort of search and interact with this. I then have sort of the full complement of search capabilities, across all the different aspects, and the ability to sort of really get in and effectively work with the unstructured data in a really sort of rich and meaningful fashion. What type is it? What does the document structure look like, or the data structure look like? So again, all of these different ways in which I can now work with that effectively 80% of unstructured and dark data in sort of really nice and easy fashion. So again, lots of ways in which I can work with it, but that's not really what we want to talk about. So again, we kind of jump back over. And so again, I've noticed that I have sort of the couple of different links. So we explored this document, but maybe I actually want to sort of, instead of just exploring it at a document or node and edge level, I really want to sort of start to take those next steps. And so I can come in, and from my custom action perspective, oops, let me make my selection. I now, instead of want to opening that specific item, I actually want to execute a search. But so I'll go back and now I'll search sort of the full text. And so again, it's not just about the nodes and edges, but now we're searching the full text of all of that unstructured information. So again, you could imagine sort of when John was talking about all of the different types of data, if I have documents, if I have presentations, if I have Excel files, if I have log files, wherever that source data has come from, it can now be sort of, it's indexed into the Nuix engine, and now it's available for search. And so here, now I'm just looking across all of the documents that contain this, and this could be a tremendous amount of information. Like we're talking about terabytes, and in some organizations, hundreds of terabytes of information that is searchable at your fingertips. And when we sort of think about all of those different things, it's how do you sort of think about building the most meaningful and knowledgeable and useful curated knowledge graph? And so when I drive that, I can flick down through each one of these things and really start to get a flavor for it. And if I want to go kind of back the other direction, it's pretty easy. I can essentially now want to take that item and open it up and essentially view that specifically in Linkurious. And so now I'm back to sort of an individual document view. And so on a document view, let's sort of take a look at sort of all the things that we can expand. So again, these are all of the types of entities and all of the different aspects of the information that we've extracted from this specific document. And so you can see that it contains our person, Oliveri, contains different entities about organizations. It has URLs. And so the reality is this is all of the information that has been extracted by NLP from this specific textual document. And so now you can imagine that if you essentially sort of see all of the different elements, you're able to then effectively move between the full text of the item and all of the sort of the different sort of associated links. And so when you're sort of looking at all of that, again, trying to understand how that works, trying to understand how all of the different relationships, again, it's about being able to programmatically extract all of this information. And so you may ask, like, that's all great. That looks like a nice curated knowledge graph. I see how I can search, but it'd be great if I could actually then go out and sort of really, what I want to do is I want to understand how this gets created. It's one thing to basically by hand populate nodes and edges. And oftentimes organizations will have analysts that they're reading documents, they're pulling named entities out in order to try to create that. But this is all about being able to do this in a fast, efficient, and programmatic fashion. And so with that, as part of Nuix Neo, we actually have an automation layer. And so the automation layer allows us to use a templated approach in which we can drive an end-to-end process. And so that end-to-end, like we sort of on the slide, we had the ETL, there's so much more to it than just pull it out of a relational database and push it into the graph. So everything from being able to ingest all of the sort of raw source data, do things like deduplication. We then do things like optical character recognition. So again, when we talk about unstructured data, it's not just textual documents, so emails, et cetera, but we can also actually go in and OCR image data. So again, go in, convert that textual document into text, and then feed it through the process. We can then run it through sort of different batteries of analysis. So we can do things like extract PII for different use cases. So depending on how closely you're watching, this is actually a cyber breach notification workflow where essentially we're trying to drive a specific outcome using the engine for text and metadata extraction, NLP for enrichment, and then the graph visualization to understand how different people are related, as well as who might need to be notified. And then as you kind of continue down over here, essentially we want to think about pushing the right information into the graph. So there are multiple checkpoints along the way in which we can start to think about, okay, I'm going to deduplicate. I might run some keyword search. I might then sort of do some other processes and effectively make that decision as to what goes into the graph. And so in each one of those decision points, what we've learned along the way is there's a lot of really messy data out there and all that unstructured data. We need to have a lot of tools and techniques and procedures and basically part of the workflow that allows us to go from that giant pile of 80% garbage into something that is useful. If we push everything through the graph, it gets too messy and you start to, again, lose the intended value. So again, lots of different ways in which you can automate that process and essentially drive that. And again, as you can see, lots of ways in which this can be customized and tailored to your specific use case or your specific organization. And so that's essentially the template. So the template is essentially, how you want your workflow to run. You could just as easily come in here and say, I need to create a new job. I'm going to create the Cyberbleach workflow job. I need to define my ingestion. And so when I go to define my ingestion, essentially I can pick from data either that exists off the file server. I can connect to Amazon S3 buckets. I have other ways in which I can target Office 365 and other cloud-based shares. But the whole idea is if I sort of define these items, I can check my settings that are on my template, and then essentially I can just hit the submit button. And that workflow will kick off and drive data through from source information all the way through. It'll push it up to NLP where it's enriched. And then subsequently, it'll sort of drive sort of the curated information into the graph. And so we've talked about a bunch of different steps along the way. So we've talked about the raw ingestion, which makes that information available for search. We've then also talked about, what it looks like to visualize it, something, like sort of understanding the relationships and sort of which types of entities are extracted. We've looked at sort of how the different documents can relate to each other through common entities or shared or clustering or any of the other sort of graph capabilities. And then, but what we haven't touched on is what does it mean to actually come in and take a look at what the NLP piece is doing itself. And so the NLP piece is really sort of where the intelligence happens. So what I'm going to do is I'm going to grab the text of this document. And so I assure you that all of this happens programmatically, but for the sake of the demonstration, it's worth basically bringing it into view. So essentially, we've got the componentry, we're driving the data, end to end through the Neo process. But it's really important to sort of understand what and how Nuix Neo's NLP or AI capabilities are being used to enrich the data. So what we'll do here, I guess sort of what I should start with, is so this is the Nuix NLP model builder. The model builder is used to allow non-data scientists to build, define, and train their models, as well as push and pull and define sort of all of the different extractions. So how we started with the sort of the extraction, we started with sort of essentially a Bitcoin entity. And so that Bitcoin entity was basically extracted from the free text of this document. You could imagine that if you had sort of other reference data where you could be able to pull and push and pull and link those two things together. And so what we have, and for what it's worth, people may look at the amount of time it takes to sort of do that extraction. That's actually just to render the document editor's UI. Behind the scenes, when this is processing, we're sort of targeting, or actually we're able to do 70,000 characters per second, and that averages out to 1 million documents per day. So again, there's an easy way in which you can push a lot of data very, very quickly through this. And what we're seeing here is these are all the types of information that are extracted. This information is extracted and then pushed back into the Nuix case where it's then searchable. So again, it's about overall enrichment. And so when you start to see these types of things, we can come in here and take a look, and sort of for each one of these, we have things like what are the entities that are extracted? What are the geolocations for any of these individual facts? We have things like being able to determine that there's a person entity. We're extracting and pulling out dates. We're understanding significant terms. We're looking for and understanding monetary values, different locations. Get down here and you'll sort of recognize, this was effectively our Bitcoin address. And so again, it's those building blocks that allow you to start to sort of see how that information is extracted. And so beyond that, we're also telling you that, this document is largely about government and politics. Again, these are our out-of-the-box models. And also it's, sort of, again, the main topic is about economics and finance. And so within each one of these, when we think about classification, categorization, the amount of information and enrichment that is applied to each one of the items that is run through this process is fantastic. So again, we're looking across our different dictionaries to be able to tell you sort of what we think these documents are about. And again, it's an important distinction that each one of these numerical values is effectively searchable. And so by making that searchable, it really starts to reduce and remove some of the fear this is a binary classifier or it's something along those lines. So again, really powerful extraction allows us to get in there, understand that, and really sort of do all of this stuff, again, out of the box. And so again, we do things like named entity extraction. We do things like then the compound lexemes. And really the compound lexemes are the key to how we build a sort of curated knowledge graph. So you'll notice instead of having sort of like just tons and tons and tons of noise that's added into the graph, we focus much more on adding in the compound lexemes. And what a compound lexeme is, it's basically a contextualized regular expression. And so to build one of those, or essentially to sort of look a little bit under the hood, I'll go and sort of pop into my compound lexemes. Oops, guess it logged me out. I talked too much.
This is indeed a real live demo, and you just put that.
Yeah, absolutely. So that's often, John, the problem that I run into is that I talk too much and things time out behind the scenes. So essentially what we've got is we sort of jumped into the compound lexemes, and essentially this is a multi-layered aspect. So things start with essentially a simple regular expression. And anybody that's tried to do or build a knowledge graph with regular expressions knows how difficult this can be. So a Bitcoin wallet ID is pretty unique, but you can also have things like US Social Security numbers, which is essentially a 9-digit number. Or, if you're looking for something that's a 10-digit number. Essentially, the point is if you're building a knowledge graph off pure regular expressions, you're going to get a tremendous amount of garbage. And so this is really where it comes into sort of that overall curation process. And how do we sort of take that, narrow it down, and make it useful? And so from there, we sort of start with the base regex, but then the real power is how do we contextualize this? And so we'll filter in on our financial ones, just sort of narrow that down and take a look at the Bitcoin address. And so what this is saying is for this specific compound lexeme, we're going to execute all of this logic. And again, it's not just keyword logic and it's not just regular expression logic, but it's understanding using a large language model how this information is contextualized. So we start with a specific regular expression, but then what we have then is multiple layers of sort of basically language understanding. So this would be part of the cryptocurrency topic and include the Bitcoin lexemes. So what that means is essentially, I'm not just interested in that regular expression or a word or two around it. I'm again trying to contextualize it as to how it's used in language. And this is very powerful and very different from sort of relying purely on the structured data. So instead of just saying, all right, well, this is a field that contains Bitcoin addresses, we're actually picking this up out of the free text of these documents. And what that then looks like is if I go to my dictionaries, and I go to, actually, let me go back there, sorry. Bitcoin, sorry, I forgot where it was. So I want Bitcoin, economics and finance, cryptocurrency. So I come back over here. Economics and finance, there we go. Cryptocurrency. And so essentially what I'm navigating through is the hierarchy of information that comes out of the box. Each one of these is a specific model that's using the language associated with it to be able to classify it and score it and very effectively contextualize it. So when that sort of the screen said that it was looking at Bitcoin, I've used a regular expression, but then I'm contextualizing that with all the types of information around how a Bitcoin address might appear in text. And it's not, again, it's not just the keywords, but it's basically how something like Bitcoin wallet is used contextually in its relationship to the compound lex or to the Bitcoin regular expression. And so as you can see, as I sort of drill down into this, it's sort of, you can go really, really deep. The importance of that is this stuff comes out of the box. And so you can, again, drive this and leverage it effectively out of the box, but it also allows you to really easily start to tailor it and understand it. And again, very much contextualize it as opposed to just relying purely on the individual models. So over here, you sort of have, again, how this item is viewed, the quality of the description. So if, again, you're adding new terms or phrases or terms of art that are unique to your business, it's super easy to sort of start to drive this and power this in a consistent, repeatable fashion. And so, all of this effectively is the backstory that allows us to think about how we can go from end to end from that process perspective. But at the end of the day, like that's really sort of, how the process works, what are the components, how you can sort of navigate back and forth. But really what you're after is not necessarily needing to, in essence, navigate these different pieces. This is really powerful. But what you want to do is you want to be able to ask questions and you want to be able to understand the relationships. And so one of my favorite movies is Usual Suspects. And sort of the super bad guy in Usual Suspects is Kaiser Soze. And so the whole point of the movie Usual Suspects is trying to understand how different people might be related to Kaiser Soze, this mythical bad guy. And so for us, if they had a graph database that had all of the different pieces of unstructured information, it might be police reports or crime reports or different types of information about travel, you might be able to come in and basically say, okay, well, I really want to know if Oliveri is in any way related to Kaiser Soze. And so the easiest way to do that is essentially to ask the graph. And so what we've done is we've essentially, because we've put all of this information, all of this contextualized extracted entity information from unstructured data into the graph, I can come in and, amongst other things, ask it to find me the shortest path. And so when I ask it to find the shortest path, we're basically interrogating the graph and saying, how do I go from Kaiser Soze to Oliveri? And so again, it's just a simple graph query, but incredibly powerful. And so now if I sort of say, okay, well, that may be a little bit sort of tricky to look at. Let me come in here, adjust my layout. I want to go top to bottom. And really, I want to know, how does Oliveri relate to our criminal mastermind, Kaiser Soze? And so let me just rerun that. And so what we can see is I've got Kaiser Soze at the top. We have another potential alias to Alexandrovich through a couple of OSINT reports and basically drives all the way down to Oliveri. And so again, to try to do that, so I show it and it sort of seems really easy and okay. But in order to sort of understand those relationships across both documents and reference OSINT data that's been loaded into the system would take an analyst months. It would take them months of reading and piecing these dots together, pulling these different threads apart to be able to understand that relationship. By using Nuix Neo in combination with Linkurious and MemGraph and the entire portfolio, you essentially can feed emails at the lowest common denominator into the system. You could feed OSINT into the system. You could feed reference data into the system and effectively ask it a simple question like this. And what could take an analyst months or even years to understand across all that unstructured data, you can get results in seconds. And so really, it's that powerful capability of being able to sort of formulate and drive all of that unstructured data and then deliver it in a sort of really powerful, easy to consume user experience that makes us so excited about sort of what we're here talking today. And so with that, I'll sort of kick it back over to if we have any questions, sort of Jean.
Thanks. So let's move to the Q&A section, and maybe Cecilia, you can share with us the questions from the audience.
Yes. So if you haven't done so already, go ahead and submit those questions in the Q&A section of your screen. Let's go ahead and get started with this first question. Jean, I think this one is for you. How much does it take to get such a solution up and running? Are there any technical pre-requirements?
Maybe Stephen, you want to take that one?
Yeah, absolutely. So really the reality is that the Nuix Neo product is essentially, it's a packaged solution. I'm not going to say you download it onto your computer and run it and it all works. But essentially, it's multiple different components. But I guess what I would say is we're talking days to install, deploy, and have this system fully functional in your environment, not weeks or months. It also doesn't require customization. Like, it comes out of the box with pretty much what I showed you. I can target all of those different file types. I can process that information. It's enriched by NLP's out-of-the-box rules and driven into MemGraph and Linkurious using our predefined schemas. So again, it's not simple, but it's also done in days, not weeks, and also not done by an army of professional services and data scientists. So again, a big difference for the ability to embrace this and get going.
All right. It looks like there's a few questions here on training. So what kind of training and onboarding support is provided for users that are new to the integrated solution, and are there resources available?
So from a Linkurious perspective, we have some on-demand resources that are mostly centered on the Linkurious Academy, and that can be consumed for people eager to learn more about the software. And we can also do training for prospective clients.
Yeah, absolutely. And to sort of further what John mentioned, as part of the Nuix Neo platform, we have the Nuix Neo Advantage, which offers full end-to-end training as well as the opportunity for customized training for your specific organization.
Perfect. There's a question here. Is Linkurious integrated in Neo, or is it a separate license?
So it will be deployed as part of the Nuix Neo Investigations solution, and essentially all part of the same package from the Nuix Neo side. It's all part of the same commercial offering. And as you can see today, the integration pieces of how we operate with single sign-on, as how we can sort of move seamlessly between the two platforms. That's our current level of integration.
Next question here. How scalable is the solution, particularly when dealing with extremely large, complex data sets? And are there any limitations or considerations that you should be aware of?
Yeah, so I guess it's funny, the question around extremely large. So extremely large is incredibly subjective. So to extremely large, some people may think extremely large is 10,000 emails if they're trying to do this by hand. And that sort of requires someone to read 10,000 emails, extract these entities. And so that could be, a years long project. That's trivial for Nuix and this overall solution. When we start to think about extremely large data sets, we're starting to think about terabytes or hundreds of terabytes of information. And so when we think about hundreds of terabytes of information, you don't just essentially throw it all into the graph. You have to be diligent and intelligent about what you put through the process. So you feed it all through the front, and sort of if you look at my hands, you start with the giant funnel, and essentially what you leverage is a variety of different mechanisms such that when you put it into the graph, it's curated, so it's deduplicated. It's been filtered down to sort of relevant information that might be useful. You then leverage the NLP capabilities to do the fact extraction and the categorization, and then at that point. And then so even and sort of like that's sort of like the one push. If it then makes sense that some of that information then can be elevated to something more like an intelligence database, then absolutely. So, first sort of response to that question is extremely large. It's really all relative to sort of the problem you're trying to solve. And then even within that extremely large landscape, there's a lot of capabilities about how you can sort of push that automatically and really sort of drive a intelligent workflow such that information lands in the way you want it to.
All right, thanks, Stephen. It looks like there's another question here for you. How easy is it as a non-technical user to fine-tune the solution to detect entities and relationships for a specific context, such as forensic litigation for M&A litigation versus the analysis of clinical trial stocks?
Yeah, so I mean, at the end of the day, that all kind of goes to essentially what I was showing with the NLP model builder. I mean, I think to say a non-technical user, so let's just say my mom is probably not going to be doing that. But someone that is a professional knowledge worker that works with computers on a regular basis, that uses Google, that uses sort of online tools, they'll be able to accomplish it. We draw that distinction in that a lot of this work requires a data scientist, which is a highly, highly technical, skilled, trained individual that has, years of school trying to do this. So when we talk about sort of the no-code UI, we're talking about a no-code UI that can be used by a business professional or an investigator to be able to tune and train that. They don't have to have a degree in computer science.
Okay, looks like there's a few more questions here. Can I manually add entities to the graph?
Yeah, absolutely. So for what it's worth, Kaiser Soze, he's actually my mythical bad guy. So I added him in by hand. But I think what's also really relevant is what we found from sort of working through some use cases is there's often a time where, you have your unstructured data, but then you also have a reference set of data. And sort of like, these are my known bad guys, or these are the things that are known to be bad. And so oftentimes you preload that into the graph. And what you're then trying to do is relate back. So in the work that we're doing with cybersecurity breach notifications, the idea of having, okay, well, this is my customer list, or this is my known PII, PHI that sort of has come from the organization that's been compromised. And then we're trying to link back to it. And so that idea of being able to look at it from two ways, so I guess to answer that one, I can through the UI, I can add a named entity, but I can also load reference data and sort of visualize it in the same canvas and link that reference data to the unstructured data that we're ingesting.
Great. It looks like there's another question here, Jean, for you. Are there any other use cases other than fraud or data breach where you believe that this type of solution would be valuable?
Sure. So I can have a shot at the question. Maybe Steven, you can add some comments afterwards. So, for example, medical research. Clients are typically dealing with patents, scientific papers. It's highly unstructured, and I think the solution can bring a lot of value. Help abstract the drugs, the people, the various items that are important out of all of this out of this data. So that's one use case where we think there's a ton of value to be created. And I think, Stephen, you also mentioned a few times law enforcement. So it's also a domain where there's unstructured data. So think police reports, mobile information that can be found in mobiles. So it's unstructured. There's also the fact that it's very ad hoc. You need to start from scratch at every new investigation. And we think that the joint solution of Nuix Neo Enterprise can also unlock a ton of value in this domain.
Yeah, John, and absolutely. So great points. And one of the other ones that we sort of have seen interest is this idea of, organizations have lots of data silos. So one example that keeps coming up are things like consumer complaints, across the financial institution, where I may have inbound emails, I might have things that are texted or chatted, or, letters that are sent, or audio transcripts. Unfortunately, at most organizations, each one of those things probably lies in a different silo. And so the ability to sort of extract and understand all of that free text, risk score it to sort of understand the priority, and then visualize it. And one thing that sort of I would highly encourage anyone that just watched this video is actually to learn more about some of the things that Linkurious does around alerting, which essentially means that any time that we create a graph link or match a query, and it's not any link, but sort of it's very specific ones, you can actually raise an alert. So you can now start to think, sort of anytime, for example, I create a new link that can sort of has fewer than 5 hops to Kaiser Soze or whatever it may be, I want to know about it. So again, lots of capabilities for sort of how you can sort of take advantage and really start to think about new and exciting use cases across your enterprise.
Great. Next question here. What is the preferred database to use in Neo, Elasticsearch or Apache Derby?
Either one's fine. So that's sort of like a really in the weeds question for the Nuix attendees. You can use Elastic or Derby. It all works great with Nuix Neo. The comments about memgraph, and I see there's another question a little further down. The memgraph and the graph database, that's an additional database in addition to the Nuix case database. So it's not an either or, but we are using them in tandem. The Nuix core databases are fantastic for search. Memgraph is fantastic for understanding the relationships and being able to do fast reversals. So again, there are multiple different databases that are basically optimized for their use case.
Great. Next question here. Can the solution run fully on-premise behind a firewall, or does it require cloud-based access to any of the resources? And does this solution require specialized hardware like GPU clusters for NLP models?
So this can run 100% on-premise behind the firewall. Again, that is one of the real differentiators. And so when we talk about the use cases, we have a lot of large law enforcement organizations that need to operate in air-gapped networks. And so when we talk about large language models and we talk about our NLP, all of that is packaged and deployed on Nuix software, on sort of Nuix and Linkurious hardware. So we've got hardware partners. I noticed that there was another question in the chat about AWS EC2 versus ECS or EKS. Essentially, this stuff is software, and so we can deploy it where you need it. So it can run on bare metal. It could run in your AWS or Azure tenant. At the moment, this is software that is installed, so we are running it in EC2 instances. But we are sort of rapidly moving, and for internal purposes, we use containers. We just haven't released it in sort of its containerized format, at least from the Nuix perspective.
Great. It looks like there's just one more question here. You've talked a lot about unstructured data. Can we also use structured and semi-structured?
Yeah, so absolutely. So, a lot of the real value is when you can homogenize structured, unstructured, and semi-structured into the same system and be able to then effectively understand the relationships across that. So yeah, we focused on the unstructured data for this conversation, but Linkurious's bread and butter has been the structured data. And so the real power of what we're talking about is bringing it all together under one view, such that query I ran for shortest path can actually traverse from an ingested email to a record that's been in an HR database that's been ingested into the system. So it's really, that's the real powerful touch point, is being able to go across all of that data and sort of understand those relationships in an intelligent fashion.
Okay, so it looks like that's actually it for questions then for today. So we do want to thank you all for joining and to our guest speaker, Stephen. The webinar was recorded, so we'll be sending that out to you guys as soon as it's available. But of course, if you have any questions in the meantime, you can always reach back out to us. So thank you, everyone, and we hope you enjoyed today's webinar.
Thanks, everyone.
Take care, all. Thank you.